Sometimes, when we're building something that's really going to be great, the built-in tools aren't enough. And we want to do something more than what's available out of the box. Or we just want things to be more convenient. We want it to be easier to make requests, create servers, and talk with databases. For this, modules released by other developers, or what we call third parties, are useful. After all, it's only when collaborating with others that we can get our best work done. The good news is that Node has this really large ecosystem of libraries, or as we call them in Node, packages. Packages are these bundles of code that we can reuse. And we can find them on this site, npm.js.com, named after the Node package manager that we use to install and create these packages. When we talk about npm, there's two things that we might be talking about. The first is the npm.js website and the collection of code available through it. The second is a tool that you downloaded when you installed Node. In our command line, just like we have Node that we can use to run the REPL and execute our Node code, we also have access to npm, which is also a command line tool. We use this tool to manage and work with all of our npm packages. Because npm is bundled with the Node executable, it creates this centralized collection of code. If there's some code we want to reuse, we don't have to search all over the place on different websites and repositories to find it. Instead, we can look in one place for the collection of over 1 million packages that's available at npm.js.com. It's one of the largest collections of code in the world, and it's all completely free to use. This is one of the things that makes Node so unique and successful. Because so many developers use Node and create packages, sharing them freely on this site, even more developers join in, creating this healthy cycle where more developers want to use Node and contribute to it. This philosophy of sharing and open source has been central to Node's success. We get more learning materials, but also more existing building blocks that we can use to build up our awesome Node applications. Say we were interested in working with a database, something like PostgreSQL. We could just look for the tool we're interested in this search bar. So Postgres. And we get this list of all the packages that are related to our topic, giving us a huge head start in building our application. Let's learn all about what packages are and how to use npm to add them to our projects and work with them in the coming videos. I'll see you then. Welcome back. Let's get right into it. How do we create npm packages? But before we do that, it's worth clarifying one thing. What's the difference between a module and a package? We've learned that a module is a file that contains some code which may be exported from that module. On the other hand, a package is kind of like a collection of modules that have been packaged together. Let's make our first package and see exactly how it does this packaging. Looking back at our example from the previous section, we had a couple of different modules. Now, what if we actually wanted to implement this makeRequest function using a package that's been shared on NPM to make our life easier when filling out some of this functionality, like actually sending a request rather than just logging that we're pretending to do so? We might go to the NPM site, and because we're searching for help making HTTP requests, we could do a search for HTTP. And we get some really good options here that are quite popular and well supported. We have Node Fetch, which gives us an API similar to that which we get in the browser on the window.fetch function. We have Got, which aims to give us a more user-friendly API with a few more features. And we have Axios, which is a powerful middle ground between those two other options. So say we chose Axios. We now know that the name of our package is Axios, and we have this install command here, which I can click to copy that command, which gives us our first npm command, the install command. And so if we wanted to install Axios, we could try pasting that command into our terminal. And the I here just stands for install. So we could either type npm I for short, or write it all out with install. But when I run this command, and I scroll up here on the input, you can see that I got an error. No such file or directory as package.json. This is because to install packages, we first need to initialize our Node application with the npm tool, which will create this file for us. We do this by typing the npm init command. I'll clear the terminal here so we can see what's going on. And when I run this command inside of the Node modules example folder, I get asked a series of questions. The command first asks me what I want the package name to be. And if I just press enter, it will default to the name of the folder. And I'll get asked a few more questions. What version number? What the description should be. And I can just press enter through all of these options to get the defaults. The command will verify with me what the resulting package.json file will look like, and we'll get into this in just a second. So for now, we're just going to say, okay, yes. Now, if I knew I was going to take all of the default options for the package name, the version, description, and so on, instead of going through all those options, I could just type npm init-y, where the -y flag just means that I'm saying yes to all the questions, or giving the defaults for all the options. Either way, we can now see that we have this package.json file inside of our project, inside of our example folder. Our little program here has now been initialized as a npm package. And this package.json file describes that package. We have a name, a version number, a description. We have main, which describes the entry point for our program, what file to execute with Node by default. And then we have this script object, which allows npm to be used to automate common tasks with our package, such as running tests or running it in different configurations. For example, as a development version versus as a production version. We can include ourselves as an author, and we can also specify the license, telling other developers how they're allowed to use our code. So I'll save this for now. And because we have a package.json now, we can npm install our Axios library. Let's see what happens. Scrolling up, we no longer have an error. And we can see that Axios was added. If we close our terminal, we can now see that package.json has added this dependencies field now automatically, which keeps track of all of the packages that we've installed, as well as the version that we're using. We could now add a script, adding a property here called start, and setting it to the command that we want to run to start our application. In this case, we want to run node https.js. So we've got the name of our command and then the command that will be run. Now in my terminal, rather than typing node https.js, we can write npm run start. And that will run our start script. Or specifically for the start script, we have the shorthand of typing npm start. For most scripts, though, we'll need to type out the full npm run and then the name of our script. We've now successfully installed our first npm package. Congratulations! And you may have noticed a few extra files and folders that were created in the process automatically. I wonder what those do. Let's keep digging, but first, let's take a well-deserved break. I'll see you in the next one. Welcome back. Why did we need to initialize our package to install our Axios dependency? Well, we needed our package.json, which only exists for Node packages. You see, most Node programs are actually packages, and they need to be packages in order to really make use of npm. You may not choose to share it with the public on a site like npm.js, which is a database of all of these available packages that we call a registry, because all of our modules have been registered on it. So you might not publish your package here. But as long as you have this package.json and your application is managed by NPM, meaning that you can install dependencies and run scripts, that means your application is a package. However, when most people talk about packages, they're talking about reusable packages, like the ones you install with NPM, like Axios. So for the purposes of the rest of this course, package means a reusable package that's been shared on our NPM registry. Okay, let's get into some fun coding. I'll see you in the next one. Welcome back. It's time to put things in action and see some third-party code being put to use. Let's start with a fresh package example folder. And the first thing we're going to do is npm init to create our package.json. And we'll pass in the Y flag just to get our defaults. And now we're going to install the Axios library, which we're going to use to make a simple request against Google's servers. So we have to make sure to npm install, which does two main things. First, it downloads all of the code from the Axios package into a folder called Node Modules, which we can see here. And second, it automatically modifies our package.json to keep track of the Axios library as a project dependency. And it also tracks the Axios library inside of our package-lock.json. We'll talk about those in a moment. But let's start by putting our Axios library to use. And we're going to do so inside of a file we call request.js. The first thing we do is always to require our Axios library. From there, let's find out what functionality Axios allows us to do. We can always start on the Axios page in our NPM registry. Scrolling down, we'll see some documentation. So let's look at the features. Axios works both in the browser and Node.js. It does this by making use of the appropriate APIs on both. So in Node, it'll use the HTTP module that we've already seen and used. And on the browser, it'll use similar functionality using this standard XML HTTP request, which is available in all browsers. But in addition to doing what we can already do, it also supports a promise-based API that we can use with modern Node features like async await. This will make it a lot easier to use and to do things like handling errors. It also adds some additional functionality, like automatically transforming and handling JSON data. This will be really useful because many of the APIs that we use on the web, that we get from these services, which we can use to send emails, for example, or authenticate with Google, almost all of those services use JSON. So we want it to be easy and automatic to work with that data. And there's some more functionality, like We can cancel requests once they've already started. And we can do things like checking on the progress of a request to see how far away from completion it is. Say we were doing a large upload, and we wanted to know how long it would take. Now, what does this promise-based API look like? Let's do what we did with the HTTP built-in and see how it looks with Axios. Remember that we made an HTTP request to get some data from Google. We can do this using the Axios.get function and pass in the address, whether it's HTTP or HTTPS, as a parameter. But rather than using a callback and passing it in as the second parameter, we're going to use this cleaner promise-based syntax. We're going to say once Axios.get has gotten the response from Google, so .then, we're going to do whatever we pass in to this callback function. And this callback function takes in the response, with which we can do something like, say, print out the result. Now, again, I'm using the arrow syntax here, but we can use this fancy VS Code feature here to convert it to an anonymous function. We could type it out this way as well. And by hovering over it, I can convert it back. Both ways work. Let's test this out. In my terminal, I'll do node request.js. Check it out. We already have the functionality that we got from the built-in HTTP module. But we can actually do so much more. Say I was a bit tense, and instead of typing www, I typed a few extra W's. This is now an invalid address. So if I make this request and I rerun the program, I get this long error here that tells me something about an unhandled promise rejection warning, because my address on the internet wasn't found. The good news is that I can handle these errors really easily using the .catch function that promises give us. So I'll chain the .get function with .then, and then we're saying if either of these two blocks here failed, then we can catch an error, and we'll get back this error object here, which gets passed to our callback function in this block. And I can log this error. Now, if I rerun this application, I get this nice-looking error object that's being printed out, which is much easier to read and gives us some extra information on why that request failed. This is already extra compared to what the built-in module gave us. Now, I could also keep chaining more functions. If I wanted something to execute whether there was an error or not, I could add another .then here, which gets executed when all of our handling above has completed. So this happens when we're all done, regardless of what happened above. So we got our error, but at the bottom, we get our all done message. Now, because Axios is returning a promise, we can choose to use the .then syntax or the .then functions that are returned from this promise object that is returned from axios.get. And the reason why we can keep chaining these functions is because each of these .thens or .catches returns their own promise, which when it completes, or as we say with promises, is resolved, allows the next callback in the chain to be executed. Now, remember, our example here is now a node package. So if we wanted to npm start it, we would add start as a script in our package.json. And we would point it to run node request.js. So now in our terminal, and let's fix our request so that it's pointing to the actual Google address. And now in our terminal, we can do npm start, getting back the success response from Google. We've now unlocked the power of third-party modules with their easy-to-use promise-based APIs, which means that we're nearly ready to start making projects. But first, I don't want to leave you hanging. Let's find out about that Node Modules folder and the package lock file. These are two things that we'll be seeing a lot, so I want to make sure that their purpose and behavior is really super clear to you. I'll see you in the next one. Welcome back. So what's the deal with this Node Modules folder? Well, it contains all of the modules that we install from npm. It's in the root of our package, right next to our package.json file. When you run npm install on a package like Axios, that package is downloaded from the npm registry, and it's saved in your Node Modules folder. Node now knows to look up that dependency in your Node Modules folder when you call the require function. If we open up the Node Modules folder, though, we see that there's two folders here. One for Axios, but then one for follow redirects, when we've only installed one package and included it as a dependency for our application. What's going on here? We must be missing part of the picture. Well, each of these folders contains the full source code for that package. We can actually learn a lot just by browsing it and seeing how things are implemented. And we could even update the code to any of these functions, and that's the code that would be used in our project. But this is a bad idea. The code and files that are in our Node Modules folder should always be managed exclusively by npm and through your package.json. If somebody npm installs all of the same packages and package versions that you've installed, they should be able to replicate the Node Modules folder that you have in your project. Okay, so we're not modifying the code here. But where is this second folder coming from? Well, if we go into the package.json for Axios, which we can actually browse, And if we scroll down to where it says dependencies, we can see that Axios depends on one library, and that's the follow redirects library, which is a version of the HTTP and HTTPS modules that follows redirects. So it follows the link if a web server has been configured to redirect you. Say if you're using a URL shortening service. In these cases, the follow redirects package will handle the request properly. So because Axios requires this package, npm includes it in our node modules folder. You see, the node modules folder doesn't just have your direct dependencies like Axios, but also the dependencies of those dependencies. Our dependencies create what's called a dependency tree. Much like our modules, which also created a tree, we have our package that we've installed, which depends on this follow redirects package. And so we need to include both in order for our application to run. If Axios depended on another library, another package, we would need to have that package installed in our package as well. Rather than JavaScript files, which in Node are modules, we have these groups of modules, which we call packages. But the relationships still apply. When npm looks at these dependencies, it throws them all under the node modules folder, all side by side in this flat structure. Rather than having follow redirects inside of Axios, we put it beside Axios so that if another package wants to use follow redirects as well, we don't have to duplicate it in our node modules folder and have many unnecessary copies of it sticking around. There's this running joke in Node that the node modules folder is the heaviest object in the universe. If you search node modules under the Google image search, this is probably one of the first results you'll find. And this is all because node modules gained a reputation for growing in size really quickly for large node applications. And it can get quite large. But the truth is that a lot of the bad reputation that node modules gets comes from the early days of Node, when our dependencies were duplicated and when we would have to do things like remove the node modules folder if things became corrupt during an install, which would happen fairly often. Nowadays, though, as Node developers, we don't have to worry about this. npm has improved exponentially, especially in the past few years. Now, when we share the source code to our application, we generally don't share the node modules folder. Just like I mentioned a minute ago, it should be generated from scratch by running the npm install command. So if I delete this folder, move it to the trash, and run npm install, I should get the exact dependencies that my project needs. This npm install command is something we're going to be running a lot when downloading existing Node projects. So we're going to get very comfortable typing that command. And I may have to refresh this folder, but the Node modules are now in the exact same spot from when I deleted it. Because of this feature, if you're using a repository for source control, say Git, you'll see Node modules added to a git ignore file, so that Git doesn't include it as something to be tracked and saved in your repository. We can see an example of this in the Axios package. From the page on npm, we can browse to GitHub, where Axios is hosted, right here under Homepage. And in our repository, if we scroll down, we see this .gitignore file. And under this file, we have the list of things that we never want to include in the repository, including Node modules. This would just be a waste of space. All right, so we've learned how npm manages the Node modules folder and how this folder contains all of our dependencies and any dependencies in the overall dependency tree that we need for our Node program. And it includes them in this flat folder structure, so that our Node modules folder doesn't become that giant black hole from the running joke. But what about this package-lock.json file? Let's find out in the next video. Welcome back. Before we get into the next video, I want to take a moment to mention semantic versioning. This is a way of versioning packages that uses these three numbers separated by decimal points. We have the major version, which comes first, followed by a dot, and then the minor version. The major version is for when you make completely breaking changes to how the package works. It's almost like releasing a completely new package. The minor version is for decently sized updates that add functionality, but do so without breaking compatibility. So maybe you're not changing any of the existing functions and how they work, but instead, you're just adding more options. That would be a minor version update, where you would increase the minor version, but not the major version. And finally, we have the patch version, which comes last and is generally just for smaller bug fixes. Why am I mentioning this? Packages in your package.json use semantic versioning to version dependencies. Although, be careful here. Like every convention, it's up to the package authors to actually follow that convention. If we were releasing our package, it would be up to us to ensure that for a minor version increase, that there were no breaking changes. This is one reason why it's better to go for widely downloaded, well-supported packages over relatively unknown ones. It's more likely that all those users are going to keep the package authors honest when it comes to following semantic versioning. With that out of the way, let's get into the next video. Welcome back. What is package-lock.json? Last but not least, this file makes it easier to work with a team of developers, and it helps us avoid bugs. How? Well, the package lock.json is automatically generated when we run any npm commands where the node modules folder is modified, or where the package JSON is modified. It's kind of like a much more specific description of the dependencies from our package.json. It includes not just the dependency and the version number, but also exactly where that dependency is coming from. In this case, our npm registry. It verifies that the package is not corrupt with this integrity check. And it also includes the versions and information for all of the dependencies in the tree, not just our direct dependencies. You may have noticed that the package.json has our semantic versioned dependency, but it also has this caret symbol here, which is a feature of npm that tells it it's allowed to install any version of this package as long as it's not a major version update. And there's a special case where if the version number is less than 1, the minor version counts as the major version. Because for pre-1.0 packages, they're more likely to be changing very often. Because this versioning can be fairly confusing, the people at NPM created this handy NPM semantic versioning calculator, which I'll link to in this video. We can type the name of a package that we want to check here, and then we can test out which of the versions a specific range will capture. So if we type 1.0.0, we can see that just that version will be matched. If we type 1.2.0, but we add the caret symbol at the front, we can see that all of the versions that are above this minor version, but still part of the same major version, are matched. So we have 1.2 versions and 1.3 versions also being matched. But remember the special case. So if we had version 0.8.0 being matched, this caret symbol here is now only matching the patch versions that are greater than 0.8, but not 0.9 versions. So it's kind of like treating the 8 here as a major version, and then saying that only the next place over is allowed to increase. If you're finding these rules confusing, head on over to this calculator and play around for a bit. Everything should make sense very soon. I'll just mention one more special syntax that we'll see in our packages. Say we were matching version 4.16 with all of these patch versions available for it as well. We could type 4.16.0 and it would match all of the 16 and 17 versions. But if we only wanted to match the patch versions, we could use this tilde character instead of the caret. And this matches only version 4.16 patch versions that are greater than 16.0. And if we change this to 4.16.4, it matches only the versions greater than that on the same minor version. Okay, back to our code. So this line here is only loosely describing the version of Axios that will finally be installed. So in our package lock file, we have the exact version that we're using for all of our dependencies. This means that if someone else is trying to set up their project the same as we have ours set up, with the package lock, they'll be able to get exactly the same dependencies, making sure that the minor and even the patch versions match up. It's even helpful if you just want to test something out with a different copy of your project and you want to make sure that you're npm installing the same versions of your dependencies. Remember, following semantic versioning is ultimately up to the developer. And so if one of our packages has a breaking change, maybe the developer didn't realize that it was breaking, and we've now received the update for that package, this could lead to a new bug. This is why when we share our source code, it's a good idea to include the package lock.json file to avoid any issues with semantic versioning. Let me show you an example. Say I removed the package lock file. And I also removed the node modules folder. Maybe when I was writing this application, we had an earlier version of Axios, say version 0.21.0. And I was still using this caret, which means that for pre-1.0 versions, patch version updates are still accepted. And for later than 1.0, minor version updates would be accepted as well. So Axios is 0.21.1, but when we were developing this, we were at 0.21.0. So now my coworker comes and tries to set up this project. They'll go in and npm install, which will go ahead and download the packages and create our node modules and the package lock.json. But if we look in the package-lock.json file, we can see that the version installed was actually the latest version with the .1 patch update. So my coworker is now running different code than I was, which at the very least can lead to a lot of confusion if there's a difference in behavior. If I had shared my package lock.json file with my coworker, we could have avoided this exact situation. We'd have that extra guarantee that what I experience on my machine is exactly what they will experience on their machine. And that's what package lock.json does. I'll see you in the next one. Welcome back. Let's talk about hackers. It's common for security issues to be found in some of your packages. Any complex piece of software will have some issues over its lifespan. And there's so many Node packages around for us to use on NPM, that it's likely you'll run into one of these issues soon. And it's very possible that this will be a serious security issue. That's okay. It happens. The best way of dealing with keeping your application secure is reacting quickly to keep it updated. Security is a cat and mouse game of hackers finding issues, exploits, and security vulnerabilities, and developers doing their best to patch those issues and make our software more resilient, making it safer against future security issues. Let's look at an example. When we were writing this code, let's pretend that the latest version of Axios was 0.20. And so that's the version we specified in package.json. Let's remove our existing node modules and let's see what happens when we do npm install. Node successfully installed the 0.20 version of Axios, but it's also telling us that there was a critical security vulnerability fixed in version 21.1. We can look up more information, but we also get this notification at the bottom, telling us very clearly that one high-severity vulnerability was found. To do our part in keeping our Node applications secure, the team at NPM has included this useful tool to audit our packages, meaning we can write npm audit to see if there are any security issues in any of the packages that we depend on. So if I run this, I get this notification here that there is a high priority issue that allows for server-side request forgery. That doesn't sound too pleasant. Because Axios makes requests against the internet, we need to make sure that it's talking to all of those servers available around the world in a secure way. If we don't, we're exposing ourselves pretty dangerously. So npm audit has told us that there's an issue. And now we can run npm audit fix to resolve this issue. Basically, just by updating our package to now use, check it out, the latest version. So when writing Node applications, we want to take those warnings that we get from npm audit very seriously. And we want to make sure to run npm audit on a regular basis. Now, this isn't a magical silver bullet. npm audit will only report issues that have been reported, that have already been discovered. And it can only fix them automatically if there's an available update. If there isn't an available update, it might be worth switching to an alternative library that is more secure. All right, I'll see you in the next video. Welcome back. Let's look at how we might use some useful tools taking advantage of npm to make our life as developers more convenient. So far, we've been installing our packages locally, which just means that they're saved to our local Node modules folder, specific to our Node project. The benefit of installing these packages locally is that we can share projects with our package.json and package.lock.json, and then have our dependencies be installed with npm install. There's this really useful tool called NodeMon available on the npm registry. This helps us write Node applications by automatically restarting our application when any of our source code files are changed. We do this just by replacing our node command with the nodemon command. Let's install nodemon and see this in action. So in our terminal, we'll do npm install, passing in nodemon as the name of our package. Awesome. Nodemon has been installed, and we see it under our dependencies, just like we expect. Now, the difference between Axios and nodemon is that nodemon is an executable. We use it to run our node code and restart Node if there's been a change to our source code. So one way that we can run nodemon is by adding a script, which uses it. Say we added a script called dev, short for development, and we did exactly what we do above, just saying nodemon request.js. We can now run npm run, passing in the name of our script, so dev, and nodemon will execute our request. But now if we change our source code, say instead of google.com, we want to make a request to wikipedia.org, when I save the file, you can see that my code was executed automatically. And without having to type npm start or node request.js, I have the new output from my program. And I have the source code to the Wikipedia homepage instead of the Google homepage. This makes development a lot easier. Say I had a syntax error and I put 2 dots here, and I saved my program, I immediately get feedback saying that the app crashed, that there was a syntax error, and we had an unexpected token of this dot. So we'll be using nodemon a lot in our development. But say we wanted to run nodemon without adding it as a script. Maybe we want to run it in our terminal. Just like we run node, we want to be able to run nodemon, passing in any source code file that we want. Well, the terminal will give us some message telling us that nodemon is not a command that's recognized. Unlike node, which was installed to be recognizable in our terminal, to be in the path that we use, nodemon is installed only in our node modules folder. Now that I've refreshed, I can see that nodemon has a lot of dependencies that we now need to install. But if I go to this bin folder here, actually not in the nodemon folder, but instead there's a .bin folder here right at the top of our node modules. this is where the actual NodeMon executable is available. So if I wanted to run NodeMon as a command, I would need to pass in the path starting with // for the current directory in the node modules folder and the .bin folder inside node modules, and only then passing in the NodeMon name. So this should work. There we go. But we pretty much never run things this way. It's not very convenient. What if we wanted to use NodeMon in all of our Node applications, anywhere on our computer, and on any project without specifically installing it for that project? For this, npm gives us the ability to install modules globally. We do this by typing npm install and passing in this -g flag, G for global, and then passing in the name of the module, which we want to be available anywhere. So when I run this command, we can see that Node is installing NodeMon again, and this time, instead of installing it to our Node modules folder inside of our package example, it's been installed to the Node modules folder in this directory, in this folder on my machine. That's specific to my installation of Node, rather than being specific to this package, to this application. And because this time it's been installed globally, now we can, anywhere in our terminal, type NodeMon and the name of a JavaScript file, and NodeMon will execute. So now we don't have to have all of these dependencies installed in our local project. In fact, we can even npm uninstall NodeMon, and we're not passing in the -g flag, so this will uninstall NodeMon from our project here. If we refresh our folders, you can see it's disappeared from our Node modules folder, but we can still run NodeMon in our terminal. Check it out. If we're using this tool in multiple projects, this will save some space on our machine and be a little bit more convenient. But it has the disadvantage now of making my package JSON less representative of the things I need for my program to work the way I expect. Now there's some external dependencies that need to be in place before I can run this program, at least in development mode. In general, I would suggest against installing things globally, because we want our source code and all the files in our project to be as self-contained as possible. That's what package JSON and npm are really all about. So with that, I'll see you in the next video.